Moving on to the next general technique, we have integration by parts. All right. So I'll first explain how integration by parts came about. All right, which I'll write as a short form IBP. Right. So if you recall from the product rule, if we have a product UV UX times VX and we differentiate with respect to X, what do we get? You'll get U prime V plus V prime U, correct? So what do I do? Well, if I were to integrate d dx of UV with respect to dx, I will get back UV, correct? Because that should be the logic. If you integrate the derivative, you'll get back the original function. So what do I do? Integral of d dx uv is the same as integrating u prime v plus v prime u with respect to x. Am I right? Therefore, integration by parts basically is, if I were to integrate a product of two terms, it would be integrate one and then differentiate the other. What do I mean by that? I integrate u prime first to become u. So u prime becomes u. Then I would differentiate the other, so differentiate v to give me back v prime u. So this is what I mean by integrate one. So integrate one, and then you differentiate the other. And of course, you must have two. After you integrate one, the next one will be to integrate the derivative of the other. So v integrate v prime u. So this is the idea of integration by parts. Now let's start with an example, solve a simple one, integrating x ex dx. Okay, so clearly you cannot integrate this directly, right? The derivative of x is 1, but you have a variable x, so that doesn't really add up, right? So what do? We do integration by parts. First, we must integrate one of the terms, right? So we either integrate ex or we integrate x. Let's look at integrating x first. If you also integrate x, you realize it's a never-ending sequence, right? You realize your power of x just gets larger and larger and larger. You go to x squared to x cubed, and you'll be forever stuck with this integral here. So this is not what we really want, right? So because of this, we would integrate ex first. So when we integrate ex, we get back, well, ex. So now we differentiate x to give us integral ex dx. Because if you differentiate x, you get back 1. And now you realize you get a very easy integral. And then of course not forgetting your plus c. So this is simply integration by parts. So now the next question is, okay, what if I have two different terms, right? What should I integrate first? So my technique is that think of something that is logical, right? The easier the term to integrate, that's the one that you should integrate first. So comparing x and ex, right? Ex is easier to integrate because if you integrate ex, you get back the same function, ex. Whereas if you integrate x, right, you notice your x power just get larger and larger. Is basically an infinite loop, correct? So that's not really what you want. Another way of seeing it, which is actually kind of like my way, is this acronym called LIATE. All right, what does this acronym stand for? Basically, it represents the least, okay, more like the worst choice to integrate, worst choice to best to keep, to integrate, worst to best to integrate. Okay, so L, logarithms. I mean, it's quite obvious, right? You cannot integrate logarithms directly, so forget about it. Next one, inverse, namely trigonometrical inverse, right? You cannot really integrate sine inverse either. So these two are the ones that you should stay away from. A, we have algebraic or algebra. Because if you integrate an algebra, let's say x, you would eventually get a higher and higher power. Although in some cases, if you have, let's say, an algebra and a logarithm, then you're forced to integrate algebra first, which will actually help. Next one, the second easiest one, trigo. Why? If you have sine and cosine, you realize it's going to get back a repeating thing, right? Sine becomes cosine, cosine goes back to sine, and that's fine, all right? Lastly, I think you can guess it from here, exponential, all right? So what is the guidelines here? Well, as long as you have exponential, that should be the first instinctive choice to integrate first, because it's so easy to integrate exponential. Of course, if the power of the exponential is not a linear one, then you must exercise some caution. But what I like to do is, I don't really like to follow this acronym. I would like to see what is a success of me keeping a certain term. So in this case, if I integrate EX first, I will be able to get rid of X and integrate EX directly. So it's about planning for the future, right? What happens if you integrate one and not integrate the other? Do you have a way out? So that's the type of questions that you need to ask. Okay. Another example. All right. So let's just keep on this slide. We have integrate X ln X. Okay. So obviously we cannot integrate ln X, right? So we are forced to integrate X first. So, and anyways, by the lie 8, we are going to integrate algebra first. So we have x squared over 2 ln X. Now we differentiate the other, which is differentiate ln X. Okay, so we differentiate ln X, we get back 1 over X, and therefore we just get back X over 2 dx. As such, the integral of X ln X is simply X squared over 2 ln X minus X squared over 4. And not forgetting our favorite constant C. Alright, so this is an easy guideline to follow, and this will conclude our first introduction of integration by parts.